Hi folks, thanks for coming. First of all, I am Dave Piazza from Westcott. We already established only 2 people have been here before, huh? With my seminar. Well, I hope you get something out of this. You can see it's called the Lighting for Portraiture. First of all, Westcott is a lighting company, and we have been in business since 1899, making rain umbrellas. And about 85, 86 years ago, we put a different material on an umbrella frame, and voila, we're in the photo industry. Today, we're a full-line lighting company where we make light modifiers, backgrounds, lights, reflectors, all kinds of items. But today's seminar is really not product-centric. This is more teaching you about lighting. And we're going to really get into the basics, and I build up. I feel it's important that you get a wide base of knowledge when we talk about lighting, because lighting sometimes confuses people. And we're trying to make it as simple as I can, but give you enough information that you can make proper decisions. First of all, do I have any professional photographers here? I've got about 4 or 5 hands raised. Let's define this. If you've ever gotten paid to take a picture. That's a professional as far as I'm concerned. We got a lot more hands up, maybe about half of you. Who here, strangely enough, does not own a digital camera? Nobody. Good. Who here never shot film? Never shot film. We got a newbie? What are you, about 18, 19 years old? You're 20?
I mean, I had disposable film, but never the real.
Yeah, okay. Who here does not own a digital SLR? SLR. So we're all on the same page. We got SLRs, we're in digital. Sir, what do you got?
Film camera.
Which one? A film camera.
Film camera.
Okay, that's okay. By the way, there are a lot of digital cameras out on the second floor here. Take your pick. You're going to have a lot of good ones. And digital cameras are getting so good that they really are better than film these days. But we're going to get into that. Really, what I'm going to be talking about today is just this. We're going to talk about the properties of light. There are certain properties to light that we have to be concerned about. Different types of light. There are only a few, and we're going to go over them. We're going to go through light modifiers, and a light modifier is anything that changes the property of light, anything from a cloud outside to a reflector or a softbox. And then we're going to talk about lighting patterns. I'm actually going to show you lighting patterns. So let's get started. When I talk about the properties of light, I'm talking about some very specific things that I'm concerned about. I'm concerned about color temperature, specularity, and adjustability. Now, first of all, the reason I think it's very important to go through these particular properties of light and how those properties of light are within each different type of light is we all have a style in our mind that we're trying to accomplish when we take a photograph. And typically, if we make proper decisions on what kind of lighting to use and what kind of light modifiers we are selecting to use, we can get closer to our mind's eye image. And really what it's all about is doing lighting and having a style on purpose. I think we've all taken some great pictures. The key is to be able to do it consistently and on purpose. And so that's why I go through all this. I think it's very important, and especially when we talk about digital as compared to film. Now, all of you have shot film, and digital, some people think it's changed everything. I don't think it's changed much. Photography is photography. We still are basically capturing light that is being reflected off of a subject. Technically, that's what's really going on. Light is reflecting off of a subject. It's going through glass, a lens, and being captured on a light-sensitive product. A light-sensitive product. Before it used to be film. Now it's a chip. So the basics are still there. Focus, depth of field, exposure, all that. The 2 areas that have changed the most, if anything, is color and exposure. Now, all of you have shot film, right? Color negative film? Anybody here never shoot color negative film? One person. What do you shoot, slides all the time? Who shot slides most of the time? About 4 or 5 of you. Actually, people that shoot slides are better prepared for digital than those that never did. And this is the issue. And I'm going to get back to color and specularity very, very quickly here. But I want to get this out because I think it's extremely important. There is such a thing as a latitude of exposure for any given exposure that you make. For example, when we shot color negative film, we can overexpose that color negative by around 2 f-stops and underexpose by about a full f-stop and still get an acceptable image. That's a 3 f-stop latitude. You people who shot slide film, your latitude was what? About a half a stop on the overexposure side, maybe a half a stop on the underexposure side. Correct me if I'm wrong. Am I about right? I see a nod over there. Maybe a half a stop. So we had maybe a 1 full stop of latitude. With slide film, since that was the final product after you shot it, it was very sensitive to that exposure. As you overexposed it, the slide got lighter and lighter and lighter until the image just went away. Digital is very much like slide film. It's actually like touchy slide film. Anybody really overexposed their digital images? What happens when you do it? Highlights get blown out, shadows, detail goes right away. Same thing with the underexposure, actually is a little bit better if you're going to do anything with digital. Underexposing it, and I'm talking a teeny bit, a very, very little bit. So we've got this very thin latitude of exposure that we're trying to accomplish. And then there's color. And color's a big issue. And I'm going to get this bugaboo right out of the way because this is my personal opinion. My opinion is that if you are shooting something and you know you may not be shooting it as well as you can technically, and you say out loud or tell yourself, oh, I'll just fix it later in Photoshop. Well, I'm sorry, I think that's really a bad way to do work. I'm a little old school. I mean, when I shot my very first wedding, I shot my first wedding in 1979. Way before you were born, dude. A long time ago. And when I'm shooting color negative film and I'm shooting a wedding, I shot 120 pictures for the whole wedding. 10 rolls of 120. And I couldn't see the images for a week. You know what that's like when you shoot a wedding and you can't see images for a week? We are, as digital photographers today, we are spoiled rotten with the LCD on the back of the camera, which is a great thing and it's also a terrible thing. I never had one when I shot weddings. So that trained me to do something. It trained me to have my exposure right on the money, to make sure I focused things properly, make sure my composition was good. Today, wedding photographers shoot thousands of pictures. They just shoot away and something's gonna come out really good. Well, in my opinion, if you shoot things carefully from the beginning and you choose your lighting and your technique carefully, and you get a good image coming out of the camera, then you can use Photoshop to enhance your photograph. So this discussion I'm going to have right now is all about that. It's about trying to get that image as good as you can coming out of the camera. Now, these particular subjects are important. Let's go through each one. I all have heard of color temperature, right? We all know what color temperature is. I'm going to go over it anyway because I think it's extremely important. I'm going to also talk about some of them I think are misconceptions on making adjustments in computer programs. First of all, color temperature is the color of light. That's all it is, the color of light. And technically, it is really measuring only a limited amount of the color of light. It's measuring the yellow-blue scale of light. As the color temperature number rises, and it is measured in degrees Kelvin, that is bluer light. As you have a lower color temperature in Kelvin, it's a yellower light. I'll give you an example of some numbers. An incandescent bulb, and this is a type of incandescent bulb. You all know what an incandescent bulb is. They're trying to get rid of them. And in fact, this is a type of tungsten bulb. Let's get one of the definitions out of the way right away. A tungsten bulb, which this is part of, one of, is a family of bulbs that basically produces its light by using electricity to heat up a metal element. that comprises a tungsten bulb. So they all have similar properties to them. There are many different types of tungsten bulbs. This is the lowest common denominator tungsten bulb, an incandescent bulb. An incandescent bulb like this happens to be a good one, but the one you may have in your home, little 60 watt, 25-cent bulb, the color temperature in that's around 2,700 degrees Kelvin. They last about 1,000 hours, maybe. The trouble with those bulbs and why they're terrible for photographic use is as soon as you start burning them, the color temperature and the intensity starts going down. Slow, long slide to total garbage. So when the bulb is brand new, it may be 2,700 degree Kelvin. In 500 hours, it may be 2,400 degrees Kelvin. We don't know. And bulb to bulb is different too, because the manufacturer is just trying to produce light, not necessarily a certain quality of light. The next common denominator in tungsten bulbs is what this is, a photo flood bulb. This bulb here happens to be an ECA and is a 250 watt, 3,200 degree Kelvin bulb. Now, once they put 3,200 degree Kelvin on the bulb, they have to maintain that color temperature. That's one of the reasons this bulb is rated for 20 hours of use. 20 hours of use compared to 1,000. Let me check that. The spec right here is the average life is 20 hours. And the reason that it only lasts for 20 hours is because the manufacturer is saying, okay, it's 3,200 degree Kelvin, it's going to maintain that intensity, this is the amount of time we can make it work. A 500 watt bulb like this usually lasts about 60 hours. Then you have tungsten halogen bulbs, which are also 3,200 degree Kelvin, most of them. A tungsten halogen bulb is the same basic thing where it has a metal element that is being heated by electricity. The difference is they insert gas in there, halogen gas, which makes it burn more consistently and longer. Other color temperatures are fluorescent bulbs. And we're going to talk quite a bit about fluorescent bulbs today. They range anywhere from 2,700 degrees Kelvin to 6,500 degrees Kelvin. They're all over the map. And in fact, a lot of the bulbs that we have in offices, like here, they're typically around 3,500. Liz, do you mind turning on one of these banks of fluorescent bulbs for a second? Either one of them. Okay. And I want to turn this on for a second. These bulbs right over here that I got turned on, those are daylight fluorescent bulbs. These over here, if you look at them, and then look at that, and look at that, you tell me what color those are different than this. They're yellower. It's very noticeable within your eye, isn't it? Now, what that means is that that bulb over these fluorescent bulbs up there are probably, you can turn that off now, probably around 3,800 degree Kelvin. We're not really sure. They're all over the map. When I talk about color temperature also, I am, like I told you a second ago, I am talking about the measurement of the yellow-blue scale. Yellow is the opposite of blue. As I increase blueness, I am, by its very definition, reducing yellow. And the opposite way is like that also. It does not measure the other colors that are present. And there's one color that's particularly present in fluorescent bulbs that is not present in most other bulbs, and that's green. And the color temperature will not measure that greenness. There's another spec I'm going to talk about in a second. Then we have daylight. Daylight is anywhere between 5,000 and 6,000 degrees Kelvin, approximately. Daylight, the color temperature varies quite a bit. It'll be as low as 1,000, as high as 12,000. Very, very wide ranging. We generally say that daylight is around 5,000 to 5,500 because in the middle of a day, that's approximately what it is. Now, if you all have digital SLRs, we already established that. And you all understand you have white balance presets on those cameras, right? How many daylight presets do you have on most of your cameras? No, not one, 3.
Cloudy and daylight.
Okay, you say which ones now? Daylight, cloudy, and shade. Those are the 3 most generally accepted color, white balance, daylight white balance presets in your digital SLRs. And what they're doing is they are recognizing that there is a difference in color temperature within certain conditions in the daytime. Daylight, and some of your camera manufacturers, a manual actually tells you the number. Some of them do. Daylight is approximately 5,000 degree setting in your camera. The cloudy day setting is higher because it is a natural fact. Clouds come by, color temperature rises, the light gets bluer, about 6,000 degrees Kelvin. Shade, open shade, is bluer still, around 7,000 degrees Kelvin. Some of the most blue light you see in nature is a bright sunny day with snow on the ground, something about the reflectiveness of the snow, in the open shade. It's about 12,000 degrees Kelvin. Candlelight's about 1,000 degrees Kelvin. Sunset and sunrise are very low Kelvin, so daylight's all over the place. But generally we say 5,000 to 6,000 because that's what we consider quote-unquote daylight. We have electronic flash, which typically is the same as daylight, around 5,500, 5,400, 5,300. We have daylight fluorescent bulbs that we're using today. These are rated at 5,500 degree Kelvin. So those are the differences we've got in color temperature. It's important to understand that any bulb or any kind of light that's not made for photographic use, there's a reason that it's not there for photographic use. Mainly it has to do with consistency. I'm concerned about consistency. Now let's talk about color for a second and our white balance and shooting RAW and shooting JPEGs. How many of you people shoot JPEGs most of the time? I do. I'll admit it. RAW? All shooting RAW most of the time? Okay. You shoot both? You shoot film. We have one throwback. We have one guy with a film camera and one guy that shoots film right now, and I appreciate your dedication to your art. The reason we're shooting RAW is that there's more information in that particular file, and we're able to manipulate that much easier in a computer program. You can adjust exposure, you can adjust color. There's no doubt that you can do it. Very much like when I was shooting color negatives and I went to enlarge them in an enlarger, I was able to adjust density and color to a certain extent. You can actually do more of an adjustment with a RAW file if you're good at using Photoshop or the developed portion of Lightroom than you can with an enlarger. I've already established that I like to shoot it directly out of the camera correctly. So even if I'm shooting RAW, and even if I do have that ability to change the color or the density later on, I am still trying to get the best possible photograph that can come out of the camera. Why? I don't want to spend my time in Photoshop correcting my photograph. If I'm going to spend any time in Photoshop, which I'm going to be very honest with you, I don't use Photoshop. Most of the photography I do today is for seminars like this. And I also do shooting on my own, mainly to show people and instruct them how to do proper lighting. So if I want to show photographs to people, which I do quite a bit, I travel with a lot of photographs on my iPad, none of them have touched Photoshop. Because if I'm trying to show someone what they're capable of if they just use good camera technique and good lighting, you know, Photoshop kind of makes it fake, in my opinion. So if you ask me about color and making your settings in your camera and using Photoshop, I'm going to be all on the camera. And Photoshop, as far as I'm concerned, is something very useful to take away blemishes and enhance your photograph. I'm going to teach you today how to get as good of an image as you can out of the camera. A JPEG is just a compressed file, and in fact, the developing that's being done is just done in the camera. So actually JPEGs are a little bit more consistent coming out of the camera. All the sample pictures I'm going to show you today were shot purposely as JPEGs. So I wanted a certain amount of consistency in what the pictures looked like when I made differences in color. For example, here are some pictures right here to show you a little difference in what your camera sees with color temperature. Now, these pictures are of my daughter. That's Deanna. She was 17 when I shot these. Now she's 20. She was really nice enough to pose for it. And If any of you have a teenage daughter at home, or did, you know what the left-hand picture is all about. That was the very first picture I shot during the day. She wasn't really happy with me. But anyway, this is to show you what the camera sees when it comes to color. What these were done is an illustration of what the camera sees. The picture on the left was shot with 3200 degree Kelvin light with the camera set at daylight preset. Okay? The one on the right is 5500 degree Kelvin with the camera set at daylight preset that is designed to match it. So the one on the left is showing you what the camera sees when you have the white balance set incorrectly with extremely yellow light. That's what yellow light looks like, or that's what low color temperature light looks like to a camera when you have a daylight preset. Okay? That's what the light looks like. Now, our eyes, we get thrown off a little bit. I mean, our eyes make these corrections in our brains. When we're in 3200 degree Kelvin light and we just turn the lights on and you look at someone's flesh tone, it looks natural, just the way you expect it to look. Because our brain does that. I don't know what it does. Nobody knows how the brain works, but it works, where we see that light. In fact, if you look at each other's faces right now, you're a white girl. You look pinkish to me. But in reality, if I took a picture of you right now, the camera's not going to see it like that because the exposure level is very low here, very low color temperature on your skin. This is what the camera sees. Let's talk about CRI and a little bit more technical part about lighting, and then we'll get into some lighting properties of light. Color rendition index is a term that actually measures almost the purity of light. This is the actual book definition of what CRI is, or color rendering index, or color rendition index. It basically is measuring how close that light source reproduces colors like daylight. Okay? Now I'll repeat that one. It's a little tricky. It's measuring how close a light source reproduces color like daylight does. Now that means that it's actually a measurement of the wavelengths of color coming out of a light. Most of this number, and it is a number from 0 to 100. 100 is considered daylight. Anything above 90 is considered daylight-like and very good for photographic use. There's virtually not much of a difference between a light source in the low 90s CRI and daylight. You can mix those colors. Most of this applies when we're talking about, in photographic use, fluorescent lights. I'm not going to get into mercury vapor or all these other weird lights, because really what we're dealing with most of the time when we shoot photo and video is we're dealing with daylight, we're dealing with tungsten light, we're dealing with fluorescent, and we're dealing with LEDs. I'm going to start talking about LEDs more as we go on here in the future. I don't have a lot of LED information here just because we're just coming out with them ourselves, and we're working on LEDs pretty diligently. But a CRI, in particular with fluorescent bulbs, is you can have a high color temperature in a fluorescent bulb and a low CRI. And what that's telling us is that, yes, that light source may be daylight-like in the blue-yellow scale, but typically what it's telling us if the CRI is low is that it's green. That's the nasty color that comes out of fluorescent. Yes?
So it's like the tint?
I'm sorry?
That's like the tint, the green-red tint?
Well, the question is that like a green-red tint? Not quite. They're actually, it's actually a magenta green. Magenta, which is like a pink, is the opposite of green. Cyan, which is like a bluish green, is the opposite of red. And it actually gets more complicated than that. And again, I'm not going to get into total color theory here, but suffice it to say that when we're dealing with fluorescent bulbs in particular, we're concerned about that green light. If you've ever shot in film before under fluorescent bulbs in an office without a flash, you know what I'm talking about. It comes out yellowish green. It's pretty pukey looking. Now, white balance may take care of a lot of those problems. Sometimes it will not. In fact, let's talk about the different types of white balance that we have right now. And I think it's important to understand these and get it into your workflow that you use the right combination. I use all of them at some time or another. We really have 4 different ways to adjust white balance on our camera. The first one is auto white balance, which I'm sure most of you don't use most of the time. Who uses auto white balance like most of the time? No one. I do once in a while for snapshots. It's really great. Or when I'm trying to do something very quickly. When I'm in a situation where I may have varying color of light, and I may be shooting raw, that I know I can make those adjustments later on, and I want to try and get the best picture I can, as always, but I'm in an event that I don't have a lot of time to mess around. Things are moving really quickly. There comes a point when just getting an image is more important than getting a perfect image. And as I have more time and more control of my environment, like a studio type setting, I'm way less apt of using something like auto white balance. So all these have to do with the situation that you're in, like anything. Almost all my shooting's gone to studio type shooting we're going to do today. So I use the last type of white balance, which I'll tell you in a moment. So we got auto white balance. All that's going on with auto white balance is the camera, whatever the camera sees, the light hits the sensors. It's trying to determine the most predominant color of light and trying to make that color of light look neutral. It works pretty good in a lot of situations. It gets thrown off very easily. If you have the camera and it's seeing one thing and you move the camera, it may see a different color of light and the first picture is going to look different than the second picture. If you're doing a portrait, this is where it's really particularly poor time to use auto white balance. And let's say I'm taking a picture of this gentleman. He's got a red shirt on. The red, the camera's going to see all that red, and it's going to try and compensate for it. It's going to make your skin look cyan, which is like a bluish, it looks ugly. So that's a real bad time to use when you got a predominant color. It gets thrown off. The second one are presets. We already went through some of the presets. We've got 3 different daylight presets. The other ones are very much acting like film, where that camera is expecting X color temperature. 3200 on tungsten. You probably have 3 daylight settings. You have electronic flash setting. Electronic flash setting is usually, I think it's usually pegged around 52 to 5300 degree Kelvin. You may have a fluorescent setting on there. The fluorescent setting should never be used with daylight fluorescent bulbs. The fluorescent setting is assuming that you're shooting under fluorescent lights that you see like in an office building or a store. And if you shoot it under daylight, a daylight fluorescent bulb, you're going to get a magenta cast to your picture. And then you may have, what are other ones we have?
The manual temperature selection.
That's the next one. I'm talking about just presets. Those are the big ones, right?
A couple different.
Did I miss one?
Sets also for fluorescent that you can choose from.
It depends on the camera. Some have multiple ones for fluorescent. But just suffice to say that that preset is giving you a consistent reception of color. If the color actually does change, obviously you're going to get a different cast to it. The Kelvin setting on your camera is a manual setting to Kelvin temperature. And some people like to use that because it does give you a visual difference that you can make in your camera while you're shooting. Some people like to use it as a special effect too. That's where I use it more than anything. Let's say, for example, I'm in daylight outdoors and I'm doing a portrait and I want a warm type of sundown look. If I pump up my Kelvin setting to maybe 6, 7, 8,000 degree Kelvin, 9,000 degree Kelvin, and I know that the light source that I'm shooting is around 5,000, I'm going to get this yellowish cast. It's going to give me a kind of a sundown type of glow. Oppositely, if I'm trying to make the scene look cold, which is usually represented by the color blue, I just lower my color temperature and it's going to be blue. So that's I consider it a special effect thing. I think the next type of white balance setting, if you're really concerned about color, and the one that I use all the time, is probably well suited for you, and that's custom. Now, custom white balance is actually reading the actual color of light and giving you an accurate representation of that color. In fact, today, the technique I do, I already told you that I think it's very important to get good exposure when you're shooting your digital files. Well, this device, you guys ever seen this? Called a digital calibration target. This Westcott manufactures. We don't sell it though. We do it on an OEM basis for a company called photovision.com, I think it is. Ed Pierce, he invented this thing. B&H sells this. There's many different sizes. And what Ed did is he recognized that if your exposure was not correct when you shot a digital image, it threw everything else off. And we had to be very critical in our exposure. And we also have a great tool in our cameras of a histogram. And this particular target uses the idea that we have a highlight, which is represented by white. We have a shadow in our photograph. We got a mid-tone gray. This is 18% gray. And what I'm actually going to do today when I shoot is I'm going to determine my exposure by using my light meter on this gray part, because that's what light meters do. They want to make everything look 18% gray. And then I'm going to actually fill the frame and shoot a picture of this target. And then I'm going to look at the histogram, and I'm looking for a certain pattern of the histogram to tell me that my highlight is exposed properly and my shadow is exposed properly. The theory goes is if your highlight is exposed properly and your shadow is exposed properly, all the tones in between will fall right into place. And I think it works pretty well. I'm talking about making adjustments like of a third of an f-stop. And then I'm going to use the exact same frame, and I use this to custom white balance. And it works very well. Other techniques to do custom white balance are Expo Disc. Excellent tool. Familiar with Expo Disc? Expo Disc is a filter type device that goes on the front of your camera. I own one. And it diffracts the color of light. Actually, what you do is you take a photograph of it, and it looks like a blob of gray. And you use that to do your custom white balance, and it gives you a very accurate reading too. I like to use the Expo Disc when I'm in a situation that I don't have a lot of time. Technically, you're supposed to point that towards the source of light, with the Expo Disc on, take a picture of it, and you get a custom white balance. It doesn't help a lot with exposure, not like this target does. If I'm in a studio situation like I am today, I'm going to use the target. So let's rack up this whole color thing with saying this. You have to figure out the technique that's best for you. I'm going to show you what I do when I'm in a studio situation, which does not mean you're going to use a studio situation when you're shooting a wedding or if you're shooting a sports event. So you got to figure out what you're comfortable with and what you can do easily. When I go through my procedure with the target, I know it so well, it takes me literally 30 seconds, a minute, boom, 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 I'm done. And I'm good with it. Now, it took me a little time to get there, so you got to practice it a little bit. You got to know your camera controls. And I'm just trying to help you get the best images you possibly can. Now, the next subject I think is a lot more important. And now we're going to get into some actual lighting stuff. This is what lighting's all about. Specularity is actually, you can see the definition of it. That's the definition of specularity. It's another word for contrast. It's the graduation or the difference between a highlight and a shadow. And a specular highlight, we see them all the time. All the time. In fact, you probably are seeing one right here on my beautiful bald head here, right? Is there like a point of light right here? White? And right here, right? Those are specular highlights. Different types of light have different degrees of specularity to it. Here's a good example. This is very, very common. Outdoors, bright sunny day. This is a relatively specular light. You get a highlight and you get a shadow. This actually is not terrible. But when you shoot in direct sunlight, you have issues. Sometimes the specularity gets pretty bright, especially right on the tip of her nose, on the forehead, and on her cheek. And the other thing that happens when you shoot in direct sunlight is you get raccoon eyes. Raccoon eyes are nasty. You can see it just covers up actually seeing her eye. Another bad thing about shooting in this kind of light is when someone looks at a picture of themselves, their face, what do you think they like to look at the least? Huh? Wrinkles. Oh, I think we hit a spot here, a bad spot. Who said that? Are you married? Okay, because you got to be careful when you talk about wrinkles if you're married. Actually, it's their nose, because a lot of people have wrinkles and some don't. Nose. Everybody thinks their nose is too big, right? I'm telling you, it's true. When you shoot portraits, people, they always think their nose looks too big. And there's one sure way to make someone's nose look bigger than it actually is. Put a big fat shadow underneath it. That'll do it. If the shadow from the nose hits the lips, it's too much. It's too big. Now this is relatively easy to take care of with a very simple light modifier. This is why we have diffusion panels. The first photograph was taken in direct sunlight. I didn't move anything, and all I did is I put the diffusion panel in between the subject and the sun. This acts very much like a cloud. That's what it does. What diffusion does is it disperses the light. It breaks up those specular highlights. A specular highlight is a concentration of light. Diffusion makes it bigger. And you can see the shadows kind of go away. It looks a lot more pleasant. Her eyes are open up a little bit more. I have no shadow underneath the nose. This is relatively pleasing, relatively pleasing. And in fact, I put, these are next side-by-side pictures. I like to think of specularity like this. I put it on a scale from 1 to 10 on either side, where 10 on the highlight side is white and 10 on the shadow side is black. The specularity of a picture, or the contrastiness of it, is somewhere in between. This picture on the left is probably like about a 6 and 6. The picture on the right is probably like a 1 and 1. 0, 0 is total flat lighting, where you have no shadow and no highlight. There is some highlight there. You can see it, especially on this picture on the monitors. You always see a better picture on the monitor here. You can see a highlight on her forehead, on her nose, and her cheeks. There's a little bit of shadow in different places, but it's not real deep. Now, I'm not telling you that the picture on the right is better than the picture on the left, although I think most people would say that it is. But you have to know how you actually produce those different effects. And one of the easiest ways to produce a diffused type of look is using a diffusion panel or shooting underneath a cloud. That's what clouds do. Okay, now let's get right into the types of light. We went over basically the color and specularity. Let's talk about different types. It's really simple. There are only 2 types of light that we're concerned about in photography, and that's basically continuous light and electronic flash. That's really it. Continuous light is any light that stays on all the time. Electronic flash is a light source that flashes. I could very easily put daylight under continuous light. I don't, because daylight has unique properties to it. When we talk about the different types of light, there are several categories underneath it. We're going to go through them more or less one by one. So let's get through this a little bit quicker here. We got daylight. We've already established that daylight does give good color, perfect color. When I say perfect color, it's the color that we perceive as being realistic. That's what we expect to see. That's perfect color, and that's what daylight looks like. It's very natural looking light. Typically we're trying to duplicate daylight when we're shooting pictures, typically. Unless, of course, you got a different style. I have no problem with that. Specularity is sometimes very harsh. I already said it's very easy to take care of that harshness with something as simple as a diffusion panel. Adjustability is not very controllable with daylight. I mean, we can't make the sun turn on. That's what I mean by adjustability. I have no control over the sun. Yes, sir?
Do you have to change the color temperature when you use the diffuser?
That's an interesting question. Do I have to change the color temperature when I use a diffuser? Not if you use a good one, like a Westcott one. Okay, that's my pitch of the day here. It does matter. It's an interesting question. It's an important question. And this is one of the reasons why we have photographic-based light modifiers, and then we have non-photographic-based light modifiers. I can't tell you how many people that come to me and say, well, I don't want to spend money on a diffusion panel. I just made a wood frame and I put a sheet over it. Well, yes, that will accomplish what we want to accomplish in terms of breaking up the light, possibly, but there you're going to get color issues because the material's not designed to have light go through it and reproduce colors accurately. This material is. And one of the differences in cheaper diffusion panels and reflectors and other light modifiers and expensive ones or more expensive ones is the quality of the material made. There's a special type of diffusion material that's made for photographic use. It costs more and it lasts longer in terms of it not changing color. But to really answer your question, I did not change color temperature when I took these pictures. Okay? They're exactly identical. Anytime I do, I'll let you know. Now, there are situations where I don't really have control of of the sun, for example, but I can have a couple techniques to help me out. Now here, this photograph, you can see it's relatively flat lighting, but I did not use a light modifier on this at all. There's no light modifier used, no electronic flash, nothing. This is the simplest technique that does a couple things for you that can improve your pictures when you're outdoors. I put her behind with the sun behind her. This is a very easy technique, and putting people in the shade is a very common technique when you're outdoors, no doubt about it. If you have you're outdoors and you have a selection on where you want to place someone to take a portrait, I'm trying to look for some kind of shade, but if I don't have that, and even sometimes when I do, this is a great technique because it does a couple things for you. Number one, I am putting the sun behind my subject, but I'm doing it carefully. And I learned this technique from Jim Schmelzer. If any of you guys ever come to our booth at the New York City show in October, if you never have, you should. You owe it to yourself to come to the show. It's in the Javits Center in mid to late October every year. And for the past, I don't know, 20 years or so, we have Jim Schmelzer, who's a master photographer out of Detroit, Michigan, who comes in and does seminars all day long. He does demonstrations. And he's a great photographer, and he gave me this excellent tip. He says, when I'm outdoors, he said, I don't look up in the sky to see where the sun is, because that gives me, number one, it's dangerous to look directly into the sun, but it sometimes gives me an inaccurate placement of my subject. He said, I put my hand up, and I turn around until it's fully lit. Like now, of course, I'm being fully lit because I'm being lit by that light that's right over there for the video. Now over here, you should see only partially lit on my hand for this side of the room. And over here, there, I'm partially lit. So I don't want to have the back of my subject over here. Well, I want them right here. So that gives me a good, accurate placement of where the sun is in relation to my subject. The second thing, the biggest mistake that people make when they do this is they meter incorrectly. You can't use average metering with this. What average metering does is it's going to take points of light all the way around, and it's going to give you its best guess, and it's typically going to underexpose the face. If any of you question why you have a spot meter built into your camera, this is why. All I did is I spot metered on her cheek, and I use that reading. You can see the background's kind of getting flushed away. Now, the one thing I don't like, and well, there's one other thing that it does good about this picture, is it produces what we call rim light, or a light from the rear. It highlights the hair. It gives shape to a subject. What I don't like about this is it's a little bit too flat. You know, for all intents and purposes, what we're doing with photography, especially with portraiture, is we are taking a 3D object and putting it on a 2D medium. And what a lot of inexperienced shooters do, and people that are trying to do lighting, is they try and produce this, which is getting rid of all the shadows. And they get in trouble because they put the light on one side and they get shadows. Now, I want to get rid of those shadows. They put another light on the other side. They get cross shadows. Oh, I better add another light over here or up there. Shadows are my friend. I like shadows. Shadows allow me to hide things. They allow me to shape someone's face. Okay, flat lighting is used, you see it very much in fashion photography, mainly because we're dealing with models that have nice face structure. Now, my daughter's really cute, but she doesn't quite have the face structure to handle flat lighting. And she knows this. Don't worry. I've told her. I mean, I know she's cute. I said, you know, she's not perfect. She knows it. When you look at her cheeks, they're kind of flat. So she almost has that structure to pull it off. But if I add one more light modifier, I can improve this picture quite a bit. And all I did is add a reflector. So the first picture, I just had the sun directly behind my subject. I carefully metered on her cheek. I took the picture. Then, second one, I just took a silver reflector, like this. Actually, it was this exact one. I had it on the this side of her face, warning your subject not to look at the reflector. It's very tricky when you do sun. It's incredibly bright. And now I metered with my spot meter on the highlight side. And so what this does is a couple things for me. Number one, it changed my exposure. It toned down the exposure on her hair, and it gave me a much better rim light. It gave me some depth to her face. I actually slimmed down her face, is what I did. You take a look at those two pictures, and she looks skinnier on the one on the right. And let me tell you, if you want to take a portrait of someone, you're trying to make money at it, you're trying to sell a portrait to someone, the best thing in the world you can do to make more money is to make people look skinnier. It's a fact. One of the reasons I don't like to shoot outdoors, and I absolutely hate to shoot outdoors when there's bright sun, is the very problem that you brought up. I would much rather shoot on a cloudy day. Give me my druthers, if I have a choice, and someone comes to me and they want their portrait taken, they want it taken outside, I try and talk them out of it. I like to be in a studio, because in a studio I have control. Then I can get exactly what I want. Okay? Let's go on. Let's talk about tungsten quickly. We already talked about this, so I'm going to go through it relatively quickly. There is a low color temperature tungsten light. It's yellow. Camera sees a lot of yellow. You can make a correction. The first picture was shot with a 3200 degree Kelvin source with the camera set at daylight preset. This photograph was taken, same light source with the camera set in tungsten preset. Just for the heck of it, I went to a custom white balance and I got a different look. It taught me a little bit of a lesson, where in theory, that preset should have been quote unquote perfect color for tungsten light. Well, some people would like the picture on the left, some will like the one on the left or on the right. I kind of like the one on the right a little bit. It looks a little bit more realistic to me when I see it side by side. I don't know. These are things that you have to consider. So the reason I left these slides in the program was because, wow, it taught me something, that custom white balance does give a slightly different representation. And I did the custom white balance just like I explained. I used my target. That's how I did it. So there are even differences within what is good color of light. There are slight differences. The other thing with tungsten is it is relatively spectral. When this particular photograph was taken with a light like this one over here, but with tungsten bulbs in it, it had a 36 by 48 inch box, so about this size box, with no diffusion panel on front. And that's the photograph that I got. Then the next picture, I just added diffusion to it. There's not a big difference here, but it definitely toned down the specular highlights. That's what diffusion does. But even when I tone down the specular highlights with some diffusion on the front of this box, you can still see a relatively deep shadow. And that's because tungsten light, by its very nature, has got some specularity to it. Then I add I had diffusion, then I add a reflector to make a photograph. I got a rim light on there. You can see there's some, her hair is being highlighted on the left-hand side of the photograph, her right-hand side. And so you can take a fine portrait with tungsten light. The adjustability is pretty good depending on the fixture. If I change intensity of the main light as opposed to the rim light, for example, the shadows will change a little bit. I can change the look of it just by adjusting intensity. It's a fine thing sometimes. This particular one, I'm having the hair show up a little bit more by changing the intensity of my main light in relation to the light coming out of my rim light. And this you can only do with experimentation. Yes?
So you're adjusting exposure accordingly?
On this particular one, the question is, am I adjusting exposure accordingly? And on this, actually, Yes, I changed it about a half a stop. About a half a stop.
You lowered the main light a half a stop. So
I lowered the main light so I had to adjust my exposure accordingly, but I didn't adjust the rim light.
right.
Probably one of the biggest downfalls with tungsten lamps is that they're hot. And it's just the way it is. They're all hot. And when I say hot, I mean hot. And I mean like if you touch the bulb while it's on, you're going to get a 3rd-degree burn. Is it too hot to take photographs in? Well, it depends. I'm shooting pictures of my daughter. She didn't care. You know, she didn't care. When I'm taking it in my basement, it's kind of cool anyway, and so she didn't mind it. But you know, someone like me, I'm hot if it's 65 degrees. So I get this light on me, and I'm going to be starting to sweat really, really quickly. So that's a matter of personal preference. Typically, when you're doing a tungsten shoot, like I did with this particular one, I had about 2,000 watts that I'm using, which if you do the math on that, I think it's about 16 amps, something like that. If I had it on a 15 amp circuit, I'm going to blow it. So tungsten light always pulls a lot of amperage, and if you're intending on doing some portraits in someone's home, you have to be concerned about that. The greatest thing about any continuous light is a WYSIWYG, or what you see is what you get, ease of use. Let's go on to daylight fluorescent very quickly. We've talked a lot about this. Daylight fluorescent is good color temperature. That is shot in daylight. It's soft. Now this photograph is taken the same way I had the tungsten one, but you can see there's hardly any shadow there. So daylight fluorescent by its very nature is very soft. If I add diffusion, it's subtle, but it definitely reduces the specular highlights. You should be able to see the difference here when you do a side-by-side, which means I'm not saying the one on the right is better than the left or the left is better than the right. I'm saying is there's a difference. And if I want a different look, I may have a slightly different technique. For example, if I'm shooting a female, I am typically going to a picture towards the right. I'm using diffusion because I want a little bit of a softer look on their skin. If I'm shooting a man, especially a man who's got a relatively nice looking face, an angular face, or let's say a younger male who's got some definition to his muscles, I'm using a harsher light because that shows it up better. Hollywood tells you this all the time. The next time you watch a romantic movie, any romantic movie, I don't care what it is, typically, most of the time, especially when they do the very typical scene where they have a picture of the female and then the man, you know, and then they get together like that. Take a look at what the lighting is like when they have the camera on just the female. It's a little softer, a little bit more like the picture on the right. The shadow's a little bit less. They may even use a softening filter. Okay, it looks a little soft. Then you put the same, supposedly the same lighting on the man, and it's a little bit harsher. Same thing with adjustability, where if I change the intensity, I get different looks. Daylight fluorescent bulbs are not hot. Probably the biggest advantages to them. There are several properties to fluorescent bulbs that are different than tungsten. First of all, they do not produce any heat. When I say do not produce any heat, I'm not saying they don't have any at all, but they're just warm to the touch. You will not get a 3rd-degree burn on it, and certainly your subject's not going to feel any heat. They use 75% less power. The general rule is, a very accurate rule, if you take the wattage that a fluorescent bulb is actually using, multiply that by 4, and that's the equivalency of intensity if it was tungsten. In other words, a 25-watt bulb puts out the same intensity as a 100-watt bulb. These are two 50-watt bulbs. Each one of those puts out the same intensity as a 200-watt bulb. We got about 1,200 watts of equivalency there. And they last a real long time, about 8,000 hours. WYSIWYG ease of use is the same. Now, while we're on daylight fluorescent, let's talk about LEDs really quickly. We have LED lights right up over here. These are diode-based LEDs. LED is a source, a light source that's similar to fluorescent in the respect that it does not use a lot of power, and the bulbs last a very long time, actually a lot longer than fluorescent. Most diodes will last about 50,000 hours. So they're not really designed to burn out at all. They can have several different color temperatures to them. You can actually design them to have a different color temperature. Most of them are daylight balanced. The issue with most LEDs right now is that they're more expensive, sometimes considerably more expensive for a high quality LED. There are some cheap ones out there, but they do not have a very high quality of light. The other problem with LEDs is they're not easy to modify at all. In fact, the ones we've got here is just a panel, a square panel with a bunch of LEDs, a bunch of diodes. And the other problem we have with diode-based LEDs is that when you project this on something you're shooting a video, you get multiple shadows in the back. I like to have big light modifiers, and I'm going to tell you why in a little bit. Just suffice to say that LEDs are up and coming. They're getting better and better. We have a brand new product called the Ice Light that's LED based, and you can do different things with LED that you can't do with other types of light. This, you can see, is a handheld, battery operated LED light that's using a chipped based LED, not diode based. This is one of the most advanced LEDs that are out there today. We're just about ready to bring this to market. This was designed by a guy called Jerry Johannes, a photographer out of Australia. He has got photographs that he just shot with this, and they're just astounding, because his whole thing is if you're in any kind of light situation and you want complete control of your light, what better to do than just hold it up and look and see what it looks like and turn it. This acts very much like almost like a barn door, where I can move it and I can feather light. I can put it on a light stand. It's easy, very light. Turn on anywhere. Battery will last about an hour. Pure white light, nice, clean. The power of the LED chip allows us to use a light modifier, which is this diffusion panel. Typically you don't see these, because one of the big problems with diode LEDs is that their throw is not very far. This is further. So we're able actually to produce a softbox-like light modifier in a very small, easy-to-use package. And it's fun too. You can do your Star Wars thing. Yeah, which everybody's doing, of course. It's going to be adjustable, dimmable. We're going to be able to put gels on it. It has 1/4-20 screws on both sides, so that means you can connect two of them together. There's going to probably be a lot of doodads out there that you can make a V. You can actually make almost a beauty dish type of thing, or a ring light type of thing. You'll be able to put it on a tripod with a ball head. You can hold it like that. So it's going to be a cool light. You're going to hear a lot about it. Jerry is going to be coming to B&H sometime this year to show how to do that. He might do a 2-day thing, because he likes to do shootouts outdoors, because he likes to bring it in the streets of the city at night. It's really something else. So keep an eye on LEDs. I can tell you this is that they are pricey right now. This is going to sell for $500. Give you an example. $500 gets you one light, a charger, a carry case, and clips to put gels on, which is not ridiculous, but it's not cheap either. There will be other lights that we're going to be coming out with, LED based, and I can tell you this, that they're always going to be more expensive than daylight fluorescent, at least for a while. So let's go on to flash here, and I want to go through this relatively quickly. Electronic flash is an unusual light source because it does just flash so quickly. It's different than continuous light altogether. It's a great light source, and it's a difficult light source. Probably the most difficult part about it is you don't get to see it, so you got to kind of anticipate what it's going to look like. This is a typical studio strobe. This is our strobe light. It comes with a reflector that you put on here. It's got a modeling lamp. All this is a tungsten modeling lamp. The actual light is taking place right here in the flash tube. All electronic flashes are the same in the respect of how they produce their light. Portable electronic flash. In fact, there's 4 types of flashes out there that we're concerned about. The first one is the one that's built into your camera, the pop-up guy. Useless. Terrible piece of, it's just not great. I happen to have a Canon 7D, and probably the best thing about that pop-up flash is that it'll operate this 580EX2 remotely. That's the good thing about it. But for a light source, it's really pretty poor. The next one up is a portable electronic flash like I have here. SB900, SB800, 580EX2. These are probably the most popular ones out today, Nikon, Canon. These are power horses that are fantastic for what they are. The quality of light is not that great. It's relatively harsh light, but these things work pretty well. Monolight is a studio strobe, completely different from this, where this will talk to your camera. You can actually set this on ETTL, and it'll set your exposure properly. I think all of you, how many people own one of these? Okay, let me take that back. Who doesn't own one? Only a few people. So you all know what they are. You know how easy they are to use. You put them on your camera, and it gives you good exposure. This is completely the opposite. This is stupid. Doesn't know anything. You can't connect this to your camera in any way except to fire it. So you have to have more skill when you use this because you're setting your own exposure. You're doing everything with this. The main reason we want something like this over something like this is power. This is a lot more powerful than this. In fact, this one in my right hand is probably give you 6 or 7 more f-stops than this. A lot more powerful. And then the last one is a power pack strobe. I don't even have one here because they're really not very popular these days because we don't need it with digital. This just has a power pack, and the light heads are separate from the power pack. And the main reason that those are popular, especially years ago, was power. It's all about power. A lot of power. I'll give you a good example. I'll quantify it in a couple of specs. One spec is useless and the other spec means something. The spec for this is a guide number. Anybody of you know what your guide number is on your flash? No one does, right? Believe me, there's a spec there of a guide number. Now, we're kind of lucky. I'm not sure if I want to use the word lazy, but we are a little bit lazy, where I shot my first wedding with a flash. It was a total manual portable electronic flash. Manual, which means I had to make adjustments of exposure for every single shot, and I had to calculate it in my head. Because how you do it, you adjust exposure when you have an electronic flash is through the aperture. We have shutter speeds, we have apertures, right? And if you're shooting daylight, outdoors, or ambient light, or continuous light, you have a shutter and aperture combination that you choose the best combination for whatever you're trying to accomplish. There's no perfect exposure. There's just a varying amount. There is one perfect exposure, but you can have different settings to accomplish that exposure. Do you follow that one? In other words, a 500th of a second at f2.8 is the same exact exposure as a 250th of a second at f4, which is the same as 1/125th at f5.6 and on down the line. Get that? It's important to get this too. With this, your shutter speed really is doing one thing, except for advanced techniques. I'm not going to talk about advanced techniques right now. I'm talking about the basics. Basically, your shutter speed synchronizes the shutter with the operation of the flash. All of your exposure is taking place with the aperture. And so as this flash puts out more power, and as it's closer or further away from the subject, I have to adjust my aperture accordingly. That's all measured with a guide number. All flashes have guide numbers, and they have guide numbers for different speeds and different ISO speeds I'm talking about, and feet or meters, because it all has to do with how far away the flash is. And I'll give you a really quick calculation on it, on what a guide number really means. If I have a guide, this particular flash I think is a guide number of around 200. Let's make it easy. Let's say it's got a guide number of 100. At 100 ISO in feet. What that means is that if I'm at full power and I know the distance between my flash and my subject, I can calculate my exposure. And you do it by dividing the distance that the flash is from the subject into the guide number. The resulting number is your f-stop. In other words, if I got a guide number of 100, I'm at 10 feet away, I divide 10 into 100, I get 10, my exposure is f10. That's how it works. So that's telling you a couple things. Number one, as your flash gets further away, you have to adjust the aperture wider open. Really what's going on here is all your exposures are being taking place with the aperture, which kind of takes away a little bit of your artistic adjustments you can make, and you have to be a little bit more accurate and know what you're doing if you use electronic flash, mainly because when you get rid of one of these and you use this, you have to do everything manually. Everything has to be done manually. And then you have to be worried about how you fire this thing. How many guys use one of these, like ever? A lot of you do. Then yeah, I'm telling you stuff you already know. Are you using flash meters? Who's using a flash meter? That's a good thing to have. So I don't want to get into too much detail of it because, again, about half of the group here already knows what I'm talking about. But those are the 4 types of flashes that we use. They all have the same kind of qualities, that they're relatively harsh. This photograph was taken the same way as the other ones, and you can see a very deep shadow. Very high specularity of electronic flash. If I add diffusion to it, I can definitely knock it down, but there's still a pretty heavy shadow. If I work it hard enough, and I make my adjustments, and I have a rim light and a reflector and all that, I can take beautiful portraits with electronic flash. Absolutely, positively. If I make differences in intensity, I can make very fine changes in intensity with electronic flash. So I like electronic flash for its versatility, its power, its matching of color of daylight. It's a very nice light source. But there's some things I don't like about it. Probably the most important thing that I don't like about it is the flash itself. When I'm doing a portrait, and I've got a human being in front of me, you have to keep in mind that most people in this world, let's say about 90% of them, they'd rather be in a dentist chair than in a portrait chair. Okay? You really have to keep this in mind. People do not like having their picture taken. Who here likes to have their picture taken? You? Well, then you can be my model before my model comes, all right? But there's not many of us that do. Would you admit that you're probably a little bit unusual? I'm not going to say weird, unusual. I hate getting my picture taken. Most people don't. We recognize that. And so they're in a difficult situation in the first place. And every time you're ready to take a picture, and the flash flashes in their face. Number one, it's a bright flash. Number two, what it does is it kind of trains your subject into getting more tense before you actually shoot the picture. In other words, they're sitting there. Okay, I don't want to be here. This is tough. Okay, just take the picture, will you? And sometimes when I get someone in front of me, I can see them tense up. I can see them actually, their eyes close a little bit. Then I shoot the picture, they blink, and then they relax. So I need someone to relax after I shoot the picture. We have some people that are dedicated blinkers. Anybody ever get a dedicated blinker in front of you? I mean, it's incredible, where they seem to close their eyes for every single exposure. Well, I can tell you this, folks. For you to capture someone with their eyes closed like this, they have to start closing their eyes before you shoot the picture. In other words, in anticipation of it. I'm sorry?
Isn't that usually from the pre-flash?
No, I'm not talking pre-flash at all. The pre-flash, in fact, we'll talk about that in a second. But let's talk about a studio strobe. I'm talking studio strobes now. I'm not talking portable electronic flash. Because most of the times, if we're doing a studio portrait like we're going to be setting up today, we're using something like this. There's no pre-flash in this. What this is it just flashes. If you have that flash going on, a studio, the subject is anticipating when that flash is going to fire, because when you press on the button and the flash fires, we do not have enough time to react to it and close our eyes fast enough and have it captured by the shutter. It happens too quickly. What happens most of the time when you capture someone with their eyes open is you are capturing them, and right a split second, literally probably a thousandth of a second after you capture that image, their eyes blink. It's the way it is. So if you're capturing someone with their eyes closed, typically they start closing them before you shot the picture. Now when you talk about a pre-flash with a portable electronic flash, that's a little bit of a different story. That is there ostensibly to have the camera take a meter reading of what it sees. What it actually does, and it's amazing how these cameras work, they are actually flashing the flash very quickly. That comes back in through the camera, through the lens. The sensors read it, and they automatically calculate how far away it is, how much power they should have on the actual flash, what aperture they should have set, and they all do this in a split second before it takes another a flash and takes the actual exposure. So it happens like that, really, really fast. It's really kind of amazing. And I will put to you that most people cannot close their eyes fast enough after the pre-flash. It happens too quickly. We're very slow reacting with our eyes. You can test it sometime. You know, have someone, I don't know how you can test it, but trust me, that's what's going on. So really the point I'm trying to make here is that I have this distraction of the actual flash. I'm talking about besides the specularity and all, it makes it difficult. Now, when I have continuous light, it's a different story. All of a sudden it changes the emotional setup of the whole shoot. Where I turn the lights on, they don't even know when I'm shooting pictures. Besides the fact that I can see the light, I can see what it's going to look like. I know what the image is going to look like before I capture any exposure. It's just easier. It's a much more relaxed setting. Now, I shot a picture of my daughter. You can see I actually asked her to close her eyes. And as you can imagine, a teenage girl, I actually saved the flash pictures to the end of the day. And when I started doing the flash, we did all continuous light before that, outdoors, tungsten, daylight fluorescent. Then I got to these. And literally, after I took about 10 pictures, she said, you know, Dad, this is annoying. The flash is annoying to her. I said, okay, hon, well, I'm almost done. You know, take a picture with your eyes closed, and, you know, like a typical girl, she goes, thank God, closed her eyes. I said, okay, hon, this next one, why don't you show me what it feels like when the flash fires and hits you? And that's what she gave me. Yeah. Now, when she first saw this picture, she said, you can't put that in your slide program. And I said, oh, yes, I can. It's called parental perk. The interesting thing, about 6 months after I shot this picture, it showed up on her Facebook page. So she wasn't that, you know, upset about it. But this does illustrate something very important about electronic flash. It stops action. The greatest thing about electronic flash, it stops stuff. It's hard to get a picture like that with a continuous light. That's one of the things you're giving up when you choose one light source over the other. So when I have an instance where I have a choice of what kind of light I'm going to use for a particular job, if I'm doing a portrait in a studio, I'm almost always shooting continuous light, just because I like it, it's easier. If I'm shooting a large group of people, let's say I'm shooting a group of people like this, I'm using electronic flash, because it gives me that power that I need to light up a whole area. Go ahead.
Well, continuous though, do you find that you get the pupils too small?
There's another good point. Thank you for bringing up that point. One of the differences between continuous light and electronic flash is that the pupils in your eye look different. When you're shooting electronic flash, typically you're in a darkened room and you may have the modeling lamp that's on, but the pupils are kind of large. Now, some people like to shoot large pupils. I kind of like to have smaller ones. When you put a continuous light on, pupils get smaller, you see more of the iris. These are all little things. I'm going to have to take your questions later, if you don't mind. These are considerations that will kind of change your style, depending on what your style is. Different people have different things. I'm telling you what's important to me. And I think when we get into shooting in a little bit, you are going to see how nice it is and easy it is to use a continuous light. Let's go on here and talk about very quickly, which I touched on just a second ago, where since electronic flash has got such a short burst of bright light, we don't really see that light, and we have to learn how to anticipate what the results are going to be. Sometimes the results get pretty bad. Now, certainly you can sit there and use the LCD on the back of your camera all the time and take a look and shoot a picture, look, shoot a picture, look. I kind of like being able to set up the lights and seeing it, and then concentrating on getting a pleasant expression out of my subject's face. So once I get rid of all my exposure things and what my lighting looks like, I can take more and better pictures than I can with something like an electronic flash. But I'm not putting down electronic flash. I think it's a very viable light source. It's very versatile. I'm just finding that as we have more and more sensitive LED, not LEDs, chips, digital chips inside of our cameras, it's easier to use continuous light. That's one of the reasons that the ice light is even possible. I mean, Jerry Johannes was out in the streets of New Orleans a couple weeks ago shooting this light, this final sample. This is a final sample before production, and he was able to shoot with it in the streets of New Orleans in the dead of night. And he's shooting anywhere. He's shooting with, I believe it was a Canon D3, and my associate was shooting with a Canon 7D, and we're shooting anywhere from 800 ISO to 3200 ISO, and his 3200 ISO stuff looked gorgeous. So depending on your camera, we can use ISO as a separate exposure control. So something with just 150 watts is a very viable light source. Something to keep in mind. Some people are coming to us and they're complaining that their electronic flash, their studio strobe, does not go low enough in its power because they're trying to do a portrait at f4, and they sometimes are powering the lights down as low as they can, and they're still getting f8 out of them. So we're losing a little bit of adjustment that we had, and the sensitivity of a chip is much greater than film was. So there you go with that. The simplest light modifier that there is an umbrella. Umbrella are fantastic light modifiers. My company was started with umbrellas. We started making umbrellas in 1899, so we know how to make umbrellas. And an umbrella is probably the simplest and easiest to use light modifier that there is. And here's a basic premise of light and why we would use an umbrella, why we use any light modifier. If our intention is to make light softer, and typically that's what we want to do. I've got a relatively harsh electronic flash picture right here, and it's just harsh. If I want to make light softer, there's one major way to do it. The bigger the light, the softer the light. This is a basic premise in lighting. Now, all the other things are opinion. When I tell you, you may want to choose this kind of lighting pattern, or you might want this amount of specularity as opposed to another, that's all opinion and style. This is a fact, and there's no opinion here. If you have a larger light source, it's softer. One of the reasons that a cloudy day gives softer light than a bright sunny day is the cloud is bigger than the sun. If any of you ever done bounce flash off of a ceiling, right? You've done bounce flash? How many of you here has ever done it? Most of you. And the reason you do it is to make softer light. Well, the reason it becomes softer is because the ceiling is your light source. The flash no longer is. An umbrella turns something like this, which is a 2-inch by 1-inch light source, into 43 inches. That's why it's softer. Now, and here's an example. One without an umbrella, one with an umbrella. Now we recognize that the larger the light source, the softer, which is one of the reasons we produce this guy, which is our latest umbrella. The 7-foot parabolic umbrella. It's a big butt umbrella. Now, the reason we made this is big light source. We can put a small portable electronic flash in here, and I'll guarantee you this is going to give you beautiful soft light. Any light you put in here is going to give you a nice soft light. It's got a parabolic shape to it. All that really means is there's a lot of divisions here, and it's relatively deep, so the light bounces off of it. Light travels in straight lines, except going through glass and water. Let's ignore that for a second. And anytime light, if you accept that light does travel in a straight line, which you have to, that's science, when it hits a surface at an angle, it's going to come off that surface at the same angle it hits it. That again is science. That's the way it works. Well, the reason an umbrella is so cool is that when you have this concave shape and you have a light source in it, light is hitting it in all these different parts of the arc, which means light's being spit all over the place, which breaks it up even more, which makes it softer. So that's the great thing about an umbrella. The bad thing about an umbrella is that it's not directional. Now, this picture on the left, as opposed to the picture on the right, I had an umbrella. It happened to be a 60-inch umbrella, a little bit bigger than this one. And I had on a light stand with electronic flash, a studio strobe pointed into it, and I moved it quite a bit on the second one. There's hardly any change to the shadow pattern. So an umbrella is non-directional. If what you want to do is put light in a very specific spot and you want to control shadows, an umbrella is not your guy. If you want to use it as a fill light, or if you want to light up a large area, if you're outdoors and you just want to make that light source bigger and make it softer, an umbrella is your man. But there's a big difference between directionability and non-directionability. There are different types of umbrellas in terms of what kind of surfaces they have and if they're diffusion material or not. And here's the reason we would use them. First of all, this one right here, this small guy, this is our compact, collapsible umbrella with a black removable cover. It's collapsible in the respect that the shaft goes in, so it gets very small, very easy to carry around. It's got a black removable cover, which means I can take it off. And you can see now, you should see light going through it. So if I reflect off of it with a black cover on it, there's a certain amount of reflectivity. We call this optical white. It's kind of like silver, but not quite. Certainly not like white. So it does reflect light. This, when you take the black cover off, you have a diffusion umbrella and you can shoot through it. In other words, put light through it. One of the reasons we would use a shoot through as opposed to a reflective is typically a reflective, especially if it's silver, like my large one, it's got a silver interior, it's going to maintain some specularity. And it's going to maintain intensity also. But one of the other differences we may use a shoot through over a reflective is the size of the light. There are two things that control the size of a light: the actual size of the light or the light modifier. Remember, anytime you put light into a light modifier, softbox, reflector, umbrella, that softbox, reflector, or umbrella now becomes the light source. You get that one? It's a very important fact too. Right? You know, this is my light source if I point a light into it. And so I have the physical size of the light source. Then I also have the size of it in relation to my subject. Very important. The size of the light in relation to my subject. If I have this flash and I'm taking a picture of that guy and I've got the light source right over here, well, this is pretty big in relation to the size of my subject here. If I put it further away and taking a picture of me, it's not so big in relation to me. What I'm really saying is that light in close is bigger than light further away. If I have two lights the same size and I bring one further away, this is going to be bigger to you than this. So light in close is bigger, hence softer. Now, and that applies to something like the sun. One of the reasons the sun is so harsh, it's 93 million miles away, literally. And then when a cloud comes by, the cloud is larger in relation to you. It's much closer to us. The cloud is your light source. It's one of the reasons the cloud is so soft. Now, if I use a reflective umbrella and I'm trying to take a picture of you, that's about as close as I can put it before the shaft starts getting in your face. And if I leave the light source in the same place and I use it as a shoot through, I'm closer. It's bigger. There's also an intensity difference too. When I use a shoot through umbrella, some of that light reflects off. So it actually reduces specularity even more. So if you want really a soft look, a shoot through is an umbrella to choose. If you want to maintain a little bit of specularity or intensity, a reflective one is good. Next up are reflectors. Reflectors are absolutely fantastic light modifiers. And I use them like all the time. I'm going to use one today in my shoot. They really act like a second light. The setup I'm going to do today is going to be a very typical basic lighting setup where I'm going to have the main light and I'm going to have a rim light, and I'm not going to have a fill light. This is going to be my fill light. And you can see in these photographs what it does. It just changes the whole look. And again, I'm not saying that this picture on the right is better than the picture on the left. I kind of like it because it shows her face more, but I'm still maintaining some shadow on there. So it happens to do a couple things for us. When I use a reflector off of a main light, it happens to give me a pretty decent lighting ratio between the two. A lot of people ask me, well, what lighting ratio should I have between the main light and the fill light? And I'm sorry, there's no easy question to that. A lot of that has to do with style. You know, your thumbprint, what your pictures you want them to look like. But in general, if I have a main light and I got a reflector, it seems to give me that very pleasing lighting ratio. Depending on what surface I use, all reflectors have different surfaces. Silver is probably the most popular. When we have, Westcott makes a surface called sunlight, which is an actual weave of gold and silver. So it gives warmth like gold, but it also maintains a little bit of specularity. I can actually see it on your guys' faces, you know, depending on what surface that I have. And I want to show you that when I actually start shooting. A diffusion panel can act as a reflector. This is probably going to be the softest because a couple things are happening when you have white. Number one, some of the light will go right through this, and white, just by its very nature, has less specularity than something like silver. And you can just see it. If I reflect this, I should be able to reflect the light right on my face over here from this light. And then if I use the silver, you're going to see a major difference. Right about there. And I'll show this when I actually start shooting. So reflectors, the size of reflectors do matter. If you want a softer fill light, you use a bigger reflector. But in the real world, why most of us choose different size reflectors is just for portability's sake. When I collapse this guy down, it's a lot smaller to carry than a bigger one. This happens to be a 30-inch reflector, and I travel with a 30-inch reflector because it's easier to transport. And when I put it up, it's not as big, and more people can see what I'm doing. So probably I use silver most of the time. My general rule, and this is my, not rule, but guideline, this is my style, and different people will tell you different styles. I have more of a tendency to using a sunlight if I've got lighter skinned people in front of me. I want to add a little bit of color to them. As I tend to shoot someone with darker skin, I am way more tendency going over towards silver. That's my style of shooting. Next thing up is a softbox. Now a softbox is, in my opinion, the most desirable light modifier to use, especially for portraits, mainly because it really gives you a natural type of look. It duplicates what window light looks like. It's a very directional light, where in this particular case, when I had this 36 by 48 inch softbox, and I literally moved it a couple inches, and you can see a definite change in the shadow pattern. I have a strip bank over here. And softboxes are all pretty similar. A softbox is just a box. The light is in it of some sort, and it's got a flat front. This happens to be a strip bank. This happens to be a 36 by 48 shallow box. It's made for our TD6. And this happens to be a collapsible softbox. It's good for portable electronic flash. This is our Apollo line. We've got square ones, round ones, strip banks, all kinds, where this collapses like an umbrella. But they all work basically the same in the respect that light is in it, it bounces all around, it fills up the front diffusion panel, and since you've got a front diffusion panel, it gives me directionability. Now I'm going to be using this strip bank as a rim light, and the reason I use a strip bank is because I want a long, narrow band of light, and I want it to go in a certain spot. Same thing for hair lights. I don't use hair lights a lot. Maybe it's because I'm bald, I don't know. But you know, when we actually get to doing it, doing the shoot, the general rule is if you want to emphasize something, you put light on it. And if you want to de-emphasize something, you put it in shadow. So unless you want to emphasize someone who's bald, you would never put light on my head, okay? If I've got someone with a full head of hair, I may be putting the rim light a little bit higher so it has more light on the hair. And you're going to see that, you'll be able to see it when I set this thing up when our model gets here and we shoot in probably around 15 minutes. Very noticeable too. And I have different styles depending on who I'm shooting, okay? That's where some of the lighting patterns come into play, where someone did bring up earlier about the Hollywood lighting pattern. It's a very distinct lighting pattern. And I can certainly try and do it today, although in fact, I might be able to with this one. What he brought up was this Rembrandt type lighting. And Rembrandt type lighting is light that comes from this kind of angle. It's called Rembrandt lighting because it's the kind of lighting pattern that Rembrandt had on a lot of his paintings. And the reason that Rembrandt had this lighting pattern on a lot of his paintings is that his studio used a skylight. He was using light by natural light. There was no artificial light back when Rembrandt was painting. And so this type of lighting pattern, which comes down from the top to one side, and it produces a triangle on one of the cheeks. It's very, very classic looking, very dramatic. And with the Hollywood shooting, what they did is they used tungsten light, and they used tungsten light more because that's all they had. I'm serious. Electronic flash was not invented until, I believe, the late 40s. It was not in wide use until the 50s or 60s. Any of you watch any movies that take place supposedly in the 50s or 60s, you see a lot of flash bulbs. You know what I'm talking about with a flash bulb? You've seen the movies. They got the 4x5 camera, and they got the round thing, and the thing pops like crazy, right? Some of you guys are old enough, like you, sir, that you remember them, and me too. You still have one, don't you? Actually, most of you know it, but you don't know that you know it. Any of you guys remember flash cubes? A flash cube is the same type of thing that they used in the 50s. All it really is a chemical. I was about to say, do you remember? No one should remember this. But do you remember seeing a movie of pictures taken in the 1800s where they had flash powder? That's a chemical, I can't remember the name of the chemical. Whatever the chemical is, what they had actual powder, and they literally blew it up to give you a flash of light. Well, flash cubes use the same chemical, except it's in a more solid form. It looks like a Brillo pad, and it literally blows up inside of the first ones were glass. They actually had glass bulbs, looked very much like an incandescent bulb. Then they went to plastic right around the 40s, late 30s, early 40s. They went to plastic, and most of these, again, they were shooting black and white, so they didn't care about color, so they had clear flashes. And when I say a clear flash bulb, that flash bulb would be about 3,000 degrees Kelvin. If they wanted to use any kind of other light besides a flash bulb, they would use continuous light, a tungsten bulb. And it was fine until we got to, I think it was 1935 is when color film was introduced. Kodachrome was invented in 1935. I live right outside of Rochester, and I bemoan the day that Kodachrome died. It died about 2 years ago. It's really a sad thing. But when color film became more and more prevalent, then we had to be concerned with the color of the light source. So the first thing they did was they took that flash bulb and they painted it blue. There's an M5 bulb. You probably have the blue one, sir. You take it out of the box and it's got a blue tint to it. And what that's doing is it's making that flash cube, or pardon me, a flash bulb less yellow, more blue. And when electronic flash came around, electronic flash was not prevalent again until like the 60s, 70s. That had proper color temperature that matched with film. So, getting back to our Hollywood thing, our Hollywood, the guys were using tungsten light because that's all they had. They didn't use a lot of big light modifiers because they didn't have them. They were using a bulb with a reflector with barn doors. And so when they put that light up, they gave beautiful dramatic lighting, hence the Hollywood style. Now, I can try, and near the end of our shoot, how you produce that with daylight fluorescent with a smaller softbox. That's what does it, smaller softboxes. I'm using a real big guy. When I use soft light with a big light source, a big softbox, it's going to give me soft light, very soft light. That's what my style. If I use a smaller one, if I want more contrasty or specular look, I want to show a particular lighting pattern, I use a smaller one. These are some of the choices that you make. Here, all of these pictures were taken with 2 lights and a reflector. This happens to be what we call broad lighting. And all broad lighting is, and I'll explain this a little bit more when I actually get the model here in just a few minutes. If I have someone's face and you're the camera's directly in front of me, and I got the face turned this way, the side of the face that's facing the camera, if that's the side of the face that is lit, that's broad lighting. If I have the same position like this, and I put the light over here, and I light this side, that's called short lighting. It's as simple as that. Sometimes just the turn of the head, which will produce short or broad lighting. This happens to be broad, which is one I use quite a bit with females. This is called butterfly lighting. Butterfly lighting is like Rembrandt, except the light is directly from up above, in front of them, comes down like this. Typically it's used with people that have very distinct cheekbones, females in particular. And then you have to add some fill because it will actually produce a shadow in the eyes. This is short lighting, where you can see this side of the face is facing away from the camera. It's very subtle here, but that's the side that I've got the light in. That's short lighting. And you can see the effect of continuous light on the pupils. You can really see the iris of this girl's eyes, or blue eyes. This is broad lighting, very simple portrait. And these are all relatively easy to do. This is split lighting. Split lighting is just what you think. It's split halfway across the face. If you have the face looking right at you, you've got light on one side, you got shadow on the other. Probably the best example of that you've seen is one of the Beatles albums. Remember when they had the one that had shadow on one side, light on the other? And this is a profile that's using split lighting. The light you can see is coming from the rear. A little bit of reflector. I've got the light positioned not right to the side, just a little bit over there. Kicker light, or the rim light, is lighting up her hair, and there you go. You got a photograph. I want to shoot tethered so you can see what's going on. And if any of you shot tethered before, anybody shoot tethered before? It's kind of fun. Shooting tethered, all I'm really doing is I'm putting the images directly on my computer, and I'm using Lightroom 3. The reason I like Lightroom 3 is because I don't need anything additional to shoot tethered. All I need is a cable. Lightroom 3 has built-in tethered shooting. And with Lightroom 2, you had to have an additional piece of software. So just so you know what I'm doing, to break up questions here, the cable that from here to here is what you always have. You have this with your camera. It's just a whatever connection that goes into the camera and a USB on the other side. Obviously that's only about 3 feet. And there's degradation of signal if you go to a long USB cable. Except I found this great little, it's called an active USB extension cable. I'm sure they have them here at B&H. They sell for about 20 bucks. And the manufacturer tells me, I don't even know what the manufacturer is because I tape it up. I don't want it to come apart, so I put tape on it. This gives me 16-foot extension, and the manufacturer tells me you can put 3 of them together and not have any degradation in quality of signal. If you want to do wireless tethering, you're going to spend a lot more money. That's all I can tell you. And Canon makes a device that allows you to do wireless tethered shooting. It's about $800. So this cord works okay for me. There's an iFi out there, iFi card, secure digital card, but it only works with secure digital cameras. I happen to be using a 7D, which is a compact flash. So that's the story on tethering. And all I'm going to do is when I turn the camera on, it should see it right away. Once I activate tethered shooting, tethered capture, start. It's going to ask me what the session is. I just use a date, 2/7/12. And you can see on the bottom now it sees my camera. EOS 7D, right now I'm set at f4, 400 ISO, manual exposure, or my white balance is manual, and my exposure must have got moved. I got to go back to manual. There we go. So that's that. Now, actual lighting. Okay, Ricky. We got Ricky, our model. Say hi.
Hi.
Yay! This is what I do. Is I'm start the lighting from the rear. I start from the rear. And I'm going to start with my rim light. And what a rim light does is it makes a rim on one side of her face and her head. Now, you look right at me, straight on. And most of, in fact, I'm going to take a picture of this so you can see it. But right now, I've got this turned on full blast, and I'm getting a very distinct highlight on the side of her head and a little bit on her hair and her shoulder. Now, I'm going to take a picture here. Doesn't really matter what the exposure is. Let's see if we can get this thing to show you what it looks like. I have to go to auto focus. Okay, I was on manual focus. Better to look on these screens over here. Obviously, I've got the light on the front. Actually, it's showing a little bit too much. Let's go down to this. Oh, I'm sorry, I went the wrong way. Duh. Been a long week. It's only Tuesday. There we go. That illustrates what rim lighting does. I don't want, really, actually, there's a couple things wrong with this one. There's one thing particularly wrong with this right off the bat. There's light on her nose. And most of it was just because the way her head was positioned. Turn your head this way. A little bit more towards me. Right there is where we originally shot it. Most of you should be able to see the light right on her nose. This is one of the reasons I like continuous light, guys. I can see this thing. Turn your head a little bit more this way. Gone. So with her head in that position, I'm going to show you exactly what it looks like. Same settings, just to give us an idea of what it looks like. There we go. That's rim lighting. That's pretty decent rim lighting. It's a little bit hot right now. We're going to continue on with this. In fact, I'm going to bring in another light modifier in here right now. You can see a little bit of reflection right over here. And that's mainly from my camera position right over here. I can see the face of the light. It's pretty prevalent. So that means I can get lens flare. And that's where I bring another light modifier into the issue, which is called a grid. This is an 8-crate grid. 8-crate grids are wonderful light modifiers. Unfortunately, they are expensive. They're expensive because they're virtually handmade. They actually loop material through one another. But I use them as much as I can because it does a couple things for me. When you have a regular softbox like that with a flat front, you have a throw of light of around 120 degrees. This is 180, that's 120. This brings it down to about 240 degrees. So it narrows the throw of light. What it's going to do is not only narrow that throw of light, but now, without changing the position of that rim light at all, when I'm at my camera position, I can no longer see the face of the light. So the likelihood of me getting lens flare is greatly reduced now. It does cut down your light output a little bit. I'm going to still leave my exposure the same just so you see what the comparison is like. We can probably see it a little bit darker, but that flare is going to go away. See what happens? I didn't change anything, folks. I didn't change the position of the light. I didn't change my exposure. It's noticeably different. So that's good rim light. Now, I'm gonna talk about another technique right now, a little bit of a touchy subject with me, which is a hair light. When a hair light technically is a light that comes from directly above, right on the hair. It's not in my style. I'm not saying it's bad. I don't like using it. If I were to use a hair light, a grid becomes particularly important. Because at that point, when you've got that light directly above someone's head, you want to make sure you light right here and not here and not here. That's why we have strip banks and we have grids. One of the most common questions I get is, why do we have different shaped boxes? This is why. Now, my style is more, if I want to have a little bit more light on the hair, all I do is I raise the light and I angle it down a little bit. Ricky's got beautiful dark hair. So all I'm going to do is I'm going to tilt this down a little bit like this, and I'm going to raise it like that. Maybe a little bit higher. And when I'm setting my lighting, I don't use the camera until I'm ready. Ready. I can use my eyes. Now, a couple things happen with this one. I kind of like it. Number one is putting a little bit more light on the top of her head, and I'm also getting a little bit of light on this shoulder. So it gives me a little separation on both sides. So let me show you this one. My exposure, I got to open it up just a little bit so you can see that light better. I'm a little bit slow there, so let's go to 1/25. Exposure matters quite a bit when we're talking about rim light in particular, and I'll be making adjustments when I actually put the other light on. I lighten it up a little bit, but certainly we can see the highlight on her other shoulder, a little bit more on the top of her head. I'm happy with this rim light the way it is. It's giving me just the kind of depth that I want.
Why did you move it initially? Just to see variety, or?
Why did I move it up? Because I want a little bit more light on the top of her head. I want to light up her hair a little bit more. You know, a lot of that comes with what someone looks like, what color hair they have, what I'm trying to accomplish with them, depending on what their face is like. The way Ricky looks with the way I've got this light, you notice she's got kind of like a part, but her hair is coming from this side over to this side, right? So what I'm trying to do is I want to light this up. She's got a little funkiness to her hair too, a couple different colors going on, right? How many colors you got in your hair? Lots. She likes to color her hair. A lot. And I want to kind of show that. I mean, she's got great hair, so I want to put a little bit more light on it. Just a little bit too. Yes, ma'am.
You talked about needing to open up the exposure, but you can also take the light closer to her, right? Would that be the same thing?
Okay, the question is, I opened it up a little bit, but I could have put the light a little bit closer. Certainly, anytime I am working with light, And I'm working with the relationship between my exposure and the distance of the light. Lighting closer definitely changes your exposure, no doubt. If I'm doing a rim light like this, I don't really want to bring it any closer. I want the rim light behind her. I could bring it closer and change my exposure, but at this point, I'm just starting to build the photograph. So my exposure is not really taking place with my rim light. Don't get me wrong here. I'm only taking a picture of this just so you can see what it looks like. My exposure is not changed whatsoever by my rim light when I actually take this photograph, okay? It's not. All of my exposure is taking place with my main light. Rim light is an accent light. If I turn it up, whatever given exposure I have that's properly exposed for the main light, okay, I want to repeat that one. I want to get my proper exposure with my main light. And then I will adjust my rim light up or down to show more or less detail depending on what my subject is like. Typically, when I've got someone with darker hair and a little bit darker skin, I'm keeping the lights up. If I've got a blonde there, and blonde hair tends to reflect more. If I keep the lights turned all the way up with a blonde, I may get almost like a blurb of light, a blob of light. It reflects too much. And then, again, I'm just turning bulbs on and off until what looks good to me. So now I'm going to bring the main light into it, and I am doing one of the simplest lighting patterns that there is. This is either a short or broad, depending on which way your head is turned. My style, again, this is my style, is soft light that kind of wraps around, and that's one of the reasons I love this softbox. This is our 36-inch by 48-inch shallow softbox. You can see it's not very deep. This is, I believe the spec is 14 inches. Our standard 36 by 48 softbox is about 30 inches deep. The reason it's 30 inches deep is that it's really designed more and used more with tungsten and electronic flash using an inner diffusion baffle. It has to be deep. When you have electronic flash, an electronic flash light is coming from the rear. And typically, if I can literally attach this softbox to this light with a ring. This is how we attach lights or softboxes to studio strobes. This is called an adapter ring. They're made for each individual light because this part that fits on the light is made for that particular light. And then you can see there's a ring here with a bunch of holes. There are rods in this softbox that fit in the hole. The TD6, we happen to have, not happen, that's how we designed it, we have the entry holes for the softbox on the light. We don't need an adapter ring. But if I've got this light right over here, I've got a very strong, powerful electronic flash that just wants to blast its light through anything. Well, I've got to spread that light out. So in a standard softbox, I will have an inner diffusion panel. When the light hits that inner diffusion panel, it spreads the light out, fills up the front of the box. Well, the other thing that 2 layers of diffusion does, it does a couple things. Actually, 3 things. It spreads the light out so it fills up the box, number 1. Number 2, it reduces specular highlights, which is what we want with electronic flash. Number 3, it cuts down exposure quite a bit, about 2 stops. I lose 2 stops if I use a standard box with 2 layers of diffusion. Daylight fluorescent is soft. We don't need to cut down specular highlights that much, and we're concerned about exposure. So not only does this box not have an inner diffusion baffle, the front diffusion panel is very thin. It's only a 1/4 stop thick, because that's what we need. Daylight fluorescent doesn't need that much diffusion. Now, I set up my main light, and it's really pretty simple what I do with my main light. Since I have such a large source here, and I'm trying to accomplish nice wraparound lighting, I want it to look nice. All I do is put it right here. You can see, as I move the light, I can change the lighting pattern, especially there if I start feathering it, if I want some dramatic shadows. This is a straight portrait. I want nice light on her face. I want to fill in that shadow side. It's going to be hard for some of you to see this, so you may have to get up and look. But when I put this reflector in place, it's just like magic. Beautiful. Gives me a nice, and I'm going to take pictures of this. You want to stand up? Stand up. You can see this. It's really quite the addition. And I'm still getting some shadow on the one side. That's why, remember before I said, it gives you a pretty decent lighting ratio with a reflector. Well, it does. Now, I have teenage daughters, as you know. And once in a while, I'll ask them to hold my reflector for me. How long do you think that lasts before they start complaining? I think the record I have is 2 minutes, okay? And then after that, I got to pay them. Okay, if you go to 5 minutes, I'll buy you an iPhone or something, I don't know. I have a cheaper solution. And this solution, you only pay for it once. It never talks back, ever. And it will stay there forever and never complain. It's called a light stand with an illuminator arm. A very, very useful tool. Illuminator arm, designed to hold any reflector. And it's got special clips on it that will hold the reflector. Goes on top of any light stand. Got a double ball head so I can move it any way I want. When I attach it to the light stand first, I loosen it up. Now, okay, Ricky, you're looking right at me like that. I tighten it where I want it. I'm back in my camera position, seeing what she looks like, and she looks great. Of course, yeah, that's great. My lighting's done. This is my lighting. Nice lighting. You want to stand up and take a look at it. You just kind of keep your face there. I'm going to take some pictures of it. You're going to see it. Now I'm going to do my exposure now. I'm going to use my digital calibration target, okay? I have a couple different size targets. I'm going to use my small one. This happens to be 14-inch. We have 24-inch and 36 and even 6. Now all I'm going to do with this is, first of all, my camera is in manual. My camera is always in manual. My camera never goes in automatic. And I mean never. It's just not in my nature. I can work a meter and I can work this camera in manual pretty quickly. And the reason I like manual exposure control in particular is because I'm in control and not the camera. In particular, if you're doing any kind of tricky lighting condition, and this is tricky lighting condition for a light meter. And if I take a picture just of her face, and if I back up and do half a body, and I'm in automatic, I'm going to get two totally different exposures. Because the camera is going to read what it reads. I don't care what the camera reads. I care what I think is correct. Yes, I use the meter in the camera. I want to use it right now. But once I have my exposure in manual and I set my exposure properly, as long as my lights don't change in position of my subject, I can stand anywhere in the house and take a good picture that's well exposed. So all I'm going to ask Ricky to do is I'm going to ask her to hold this in front of her face. I am going to fill up the frame with it. My camera's got pretty good matrix metering. I'm going to meter on the gray in the middle, and that's what light meters do, by the way. They're trying to make everything look 18% gray. I'm going to pick my aperture shutter combination, check my meter, and take a photograph of it and what the camera thinks is correct. Then I'm going to look at my histogram. Now, when I'm doing a portrait and I'm using continuous light, I'm going to have an adjustment of shutter and aperture, correct? And there's all these different combinations of shutter and aperture that I can choose from that all let the same amount of light through. We already established this. 500th of a second at f2.8 is the same as 250th at f4, and so on. You all get that, right? You have to get it to do photography. Well, when I'm doing a portrait, one of those is more important than the other. Which one do you think is more important, shutter speed or aperture? I'm doing a portrait. Aperture all the way, because it controls what's in focus. If I'm doing a portrait like this, and I've got a pretty busy background, this is our vintage modern background, which I think looks great, I don't want that background in focus. Actually, when I'm doing a portrait, I never want the background in focus. If you want a background in focus in a portrait, you know, go to Kmart and get a portrait done. Literally, that's what they do. I hate to tell you guys, but I did those pictures one time. Not in a Kmart. You know those guys that come in your school when you're a kid and they shoot those really awful pictures? I did it for a school year. I did 30 kids in 10 minutes. And we literally had a very wide aperture, pardon me, a very closed down aperture. We had a wide depth of field because there was no second chances. This is a picture factory. You take picture, I mean, literally doing 30 kids. You know what it's like doing 30 first graders in 10 minutes? It was brutal. But I'm trying to do some artistic photography because all I care about when I take a portrait is that her eyes are in focus. It's all I care about. So I am shooting with a 24-70 Sigma lens, 2.8 aperture, which means it maintains its f2.8 through the whole zoom range. That's another choice I made on purpose. I know that a zoom lens that has a constant aperture through the whole zooming range is a little bit higher quality lens. It costs a little bit more, but that's the way it is. I choose 24-70 because I have a chip in here that's small, so it's a 1.6 multiplication on the focal length. You all know what that means, right? So this 24-70 is really acting like about a 38 to 115 or 120. And when I am shooting a portrait, I want to shoot with a slight telephoto. My technique or my style is I like to shoot between about 85 millimeters and 120 millimeters. Some other photographers like to shoot with even a longer lens. The reason that a lot of photographers like to shoot with a long lens with a portrait is because it thins up your customer's or your subject's face. It makes them look thinner. It's what it's all about, is making people look thinner, making them look better. It makes sure that the background's out of focus. It gives a better perspective. If you've ever taken a really wide angle picture and you go really close to someone, you take a wide angle, it widens them up, makes them look fat, and we don't want to ever do that. Okay, so that's some of the stuff we're doing. Now it's to go to actually shoot, like that, right in front of your face. Now, that's the picture I just shot. If I was all by myself and I'm not hooked up to a computer, I would just go to the back of my camera and go to info and I would see the histogram. I'm using Lightroom 3. I want to show you all. There's our histogram on the top right. And what you're seeing is 3 peaks, and the right-hand peak is right smack up against the end of the frame. And the one on the left is far away from the frame. That's telling me something. I'm overexposed. I shot this picture at 400 ISO, 200th of a second at f4. My meter told me that was correct exposure. It's not correct exposure. And the reason I know is because my target doesn't lie. There's no lie in here. The histogram doesn't lie. So, I don't care about my meter anymore. I have a baseline now. I'm sticking with my f4. I'm overexposed, so what do? Go to a faster shutter speed. So I'm going to do the same thing. I'm going to take another picture right up against your face, and I'm going to go up to 2/50th, and we're going to look and see what that looks like. This, of course, is a faster procedure when I'm by myself. I'm just doing it pretty quickly. It moved, but not enough. I'm going to go up to a 3/20th of a second. And I'm going to carefully fill the whole frame. And let's take a look at this. Now we're talking. This is good exposure. It's maybe a touch over, a touch. I could like to bring the left hand open space between the end of the peak and the end of the frame. I'd like to bring it over there a little bit more, but that's fine. With the way her skin is, I want her skin to pop out just a little bit. And so this is going to show you what that looks like. Well, I'm sorry. I forgot one step, my white balance. Unfortunately, I can't show you on the screen, but when I white balance a Canon camera in custom white balance, there's just two things I have to do. Number one, I go into menu and I go to custom white balance, I press OK, and then the camera goes to the last exposure I shot, and I can scroll through my pictures on the one I want to white balance with. Well, what I want to white balance to is the very last picture I shot. So I press OK again. It asks me, use WB data from this image for custom white balance. OK, I'm done. At this point, on the top of my camera, there are all those symbols when you change from the presets. You got a little sun, blah, blah, blah. With a Canon, it's like a little bow tie with a dot on it. Nikon works a little bit differently. With Nikon, you have two ways of setting your white balance, as my understanding is. Number one, you can do it live. In other words, I can put it in a custom white balance setting, and I can have her hold up the target, and I can say, okay, do this white balance. Or I can shoot a picture of it and white balance to that. Nikon's a little bit different. Just figure out which way you do it. I already set my white balance, and literally when I'm doing a shoot by myself, I'm shooting it, I'm looking at the histogram, making an adjustment, shooting the target again, it looks good, menu, bump, 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 I'm done. Only takes seconds. So at this point, my color is set properly, my exposure is set properly, I don't think about it anymore, doesn't matter. Now I can just shoot pictures. And a straight portrait like that, I'm just going to shoot one picture. Looks pretty darn good to me. Nice color, nice exposure. That's looking great.
What would be the closest preset if you had to pick a preset?
The question is, what is the closest preset? A very important question, by the way. What is the closest preset if you had to use preset with these lights? With these lights, daylight. And your daylight preset might show it a little bit yellow, a little bit, but I find it's usually acceptable. We've accomplished a decent, a nice looking portrait. There's one thing I don't like about this portrait, and it's the position of her. I'm going to give you a couple quick posing techniques. And this again is basic. We're not getting any fashion stuff, nothing cutesy. This is a straight portrait. One of the objectives I have when I shoot a portrait is I want to make people, I want their nose to look as small as I can. I want to make them look as thin as I can. And I want as pleasing of an expression as I can get out of them. This pose that she's got right now, where her shoulders are parallel to my camera position, it's called a mug shot. Literally, that's what it is. You stand in front of the camera and that's what it is. Well, the easiest way to slim someone down and give us some nice definition, I'm going to tell you two different techniques. It's just you stay right where you are and you just move like that. All I've done, and I'm going to show you a picture of this right now, I've just moved her shoulders a little bit more, looking right at, that's right, just like that. Now you see, once I get her in a decent position, at that point I can direct her from the camera position. You know, you shouldn't have to be handsy with your subject. You don't have to at all. You just direct them with your hands. Now look what I did with that. It's a little bit more, I slimmed her down, believe it or not. I slimmed her body down a little bit. She doesn't need it, but I did anyway. It allowed her to look kind of over that one shoulder. The back shoulder's now, look how beautifully out of focus it is. I love that. Now, there are two positions you can do with this, with the shoulders. And one of them is, I actually got this tip from Clay Blackmore. I want to give a shout out to Clay. Clay Blackmore is a great portrait photographer in Washington, D.C. area. And he gave me these terms about 5 years ago. He has since changed them, but I'm not sure what he calls them now. I'm going to go back to the original one because it's easier for me to remember. There is such a thing as a masculine pose and a feminine pose. Now, the reason he stopped using those words is because right now she's in the masculine pose. And you don't really want to say, oh, just I want to put you in the masculine pose to a woman. You just don't want to do that. And really the only difference here is that a woman can be in either the masculine or the feminine pose, and a man is most comfortable in the masculine pose. And the masculine pose is simply the way she is now, with her shoulders toward the light source. Now turn your body the other way. Just swing yourself around, like that. Actually, right there. This is a fairly typical feminine pose, and when you look at this one, that's a feminine pose. I'm going to give you the extreme feminine pose. Look over your shoulder. Yeah, a little bit, heading a little bit more towards me. Yeah, this is a very feminine pose, very common, very common. I can tell you this, if you put a man in this position, you better be ready to defend yourself, right? It's a feminine pose. It's just got a different feel to it. So what that really means is if I've got a man and a woman and I'm doing them together, I'm putting the female in the feminine pose, I'm putting the male to her side facing towards the light, and it looks very natural. So at this point, I've got my exposure set, my color set beautifully. Now I can ask my subject to move a little bit, and I'm going to take a bunch of pictures now because this is the first chance I've had to shoot Ricky like this. So let's do it. Nice, like that. She knows how to move her head a little bit more towards me. That's beautiful. Nice. Now I'm going to turn your body this way. Give me the maximum pose. A little bit more, a little bit more. Nice. I want to get right up on her face. She's great to shoot. She knows what she's doing. That's great. Head a little bit more towards your left. A little bit more, a little bit more. There we go. I'll bet you a dime to a dollar I got at least 5 good shots there. Now I can continue shooting forever. Everything's really set. In fact, just to show you what I'm talking about with exposure, if I come back here, she's going to be well exposed. I'm a little soft on those. I usually use a tripod. I can't in this position. And it's going to take a little time for these pictures to download. I think I'm on, am I on RAW? I don't even know if I'm on RAW or not. So it's going to take a while for these to download. You can see how far along I am transferring files from camera. 7D puts out some nice big files. Today I have shown you the different types of light, the different properties of light, what different light modifiers do, umbrellas, reflectors, softboxes, why we would choose a certain type of light over another one because of the qualities of it. We've done a very simple shoot here where we've shown you how to accomplish exposure with a nice exposure aid, the digital calibration target, and how to read a histogram, how to set custom white balance, a couple simple posing techniques, and how we can use softboxes and grids and reflectors to give us a nice portrait. Yes, we are using continuous light here. Everything I've taught you here is absolutely applicable with electronic flash or tungsten. Absolutely, positively. Slight differences, which I think I went over before, something like using more diffusion with the main light, but if I had the same type of setting with electronic flash, I would be shooting it almost the same. The only major difference I would have is that my main softbox would have 2 layers of diffusion on it, and I'd be very careful with my exposure. I'd still use the reflector. So what we're really trying to accomplish here is to give you a base of knowledge on all of these properties of light and the different qualities that light has and the different types of light. So as you try and get a certain style, you make the choices accordingly. And what I've done here is just show you how simple it is to have a basic 2 light setup and a reflector, and you can take beautiful portraits. So with that, thank you very much, and I hope you got something good out of this, and we're going to do some shooting right now.
For more information, please visit us online, give us a call, or stop by our New York City Superstore. You can also connect with us on the web.